Hey guys, Mr. Backberg here. In this video, we're going to look at rational inequalities. So as we're looking at a rational inequality, something being rational means that there's going to be a fraction in there. So for example, we could have like x plus 1 over x minus 5, and we're going to say this is maybe greater than 0. Now this could also say less than 0, this could have an equals to line, so it could be greater than or equal to 0, but the big thing here is that we've got that fraction on the left-hand side. So as we look at solving a rational inequality, so this is that same inequality that I wrote out on the last slide. To find our critical numbers, what we want to do is work with the numerator and denominator separately for a second. So we're going to solve that numerator by setting it equal to 0. I would subtract that 1 over, so we get an x value of -1. So that's going to be one of our critical numbers. But then I want to do the same thing with that denominator. So x minus 5 is equal to 0. I add that 5 over, so we get x equals 5. So these are my two critical numbers this time, -1 and 5. So I'm going to draw out my number line with 0 in the middle. -1 is on the left-hand side, 5 is on the right-hand side. And then what we want to do is we want to pick out a test value from each interval on our number line. So the first thing I want to do is pick a number that's less than -1. So maybe -2. So I'm going to take -2 and I'm going to plug it in for x on the left-hand side of my inequality there. So I get -2 plus 1 over -2 minus 5. Now on top, -2 plus 1 is going to be -1, and on bottom, -2 minus 5 is -7. Now notice these are both negative, so double negative turns positive. So this is actually positive 1/7. So on the left-hand side, when we plugged in a test value over there, we got a positive answer, so this is a positive interval. Now in the middle, I want to plug in something between -1 and 5, and I can see that 0 is in the middle there. 0 is always nice to plug in. So 0 plus 1 over 0 minus 5. On top, 0 plus 1 is 1, and on bottom, 0 minus 5 is -5. Now that negative isn't going to go away, so this middle interval is negative. And then I want to plug in a test value on the right-hand side, so something bigger than 5, so maybe we use 6. So we go 6 plus 1 over 6 minus 5. 6 plus 1 is 7. 6 minus 5 is 1, and 7 divided by 1 is just 7. We got a positive answer, which means that this is a positive interval. Now we're looking for things that were greater than 0, and greater than 0 means positive, so we want to focus on those positive intervals. So my first positive interval is that left-hand side, which goes from -infinity to -1. And we don't have that equals to line, so we don't want to include our end values. So I'm using parentheses around those. And then I've got another positive interval over here starting at 5 and running out to positive infinity. So our solution set is the union of these two intervals. So as we're looking at this example, we've got m plus 4 over m plus 2 is greater than or equal to 2. Now the first thing I notice is that we don't have 0 on the right-hand side, and we want to get 0 over there, so I'm going to subtract this 2 over to the left-hand side. So we're going to have m plus 4 over m plus 2 minus 2 is greater than or equal to 0. Now we actually need to get common denominators on the left-hand side so that we can combine all of this stuff into one fraction. So I'm going to take that 2 and put it over 1. But then in order to get a common denominator, I'm going to multiply top and bottom by m plus 2. So we're not changing that first fraction. That's still m plus 4 over m plus 2. Now if I distribute that -2 on top, -2 times m is -2m, and -2 times 2 is -4. And this is going to be over m plus 2. And then we're going to add these fractions together. So m plus -2m is going to be -m. And if I take 4 plus -4, that's going to cancel out on top. Then the denominator is just going to be m plus 2. And this is now greater than or equal to 0. Now to get our critical numbers, we set the top and bottom both equal to 0. So first I'm going to take the -m and set that equal to 0. If I divide that -1 over to the other side, then I just get m equals 0. So that's my first critical number. Then if I take the bottom and set that equal to 0, m plus 2 equals 0. Subtracting that 2 over, we get m equals negative 2. So these are my two critical numbers. So on my number line, here's negative 2, here's 0. That splits our number line up into those different intervals. Now we want to pick a test value from each interval. So on the left-hand side, I want to start with something that's smaller than negative 2, so maybe negative 3. So we're plugging that in for our m. So we get the opposite of negative 3 on top, and on bottom we get negative 3 plus 2. So on top, that double negative turns that into a positive 3, and on bottom we should get negative 1. So 3 divided by negative 1 is negative 3. So this is a negative interval on the left-hand side. Now in the middle, I need to pick something between negative 2 and 0, so maybe negative 1. So I get the opposite of negative 1 over negative 1 plus 2. So on top, I get a positive 1. On bottom, I get a positive 1. So positive 1 divided by positive 1 is positive 1. So we've got a positive interval in the middle. Then I need something bigger than 0, so maybe I choose 1 there. So I would get the opposite of 1 over 1 plus 2. So on top, I get negative 1. On bottom, I get 3. This is a negative answer, which means that this is a negative interval. Now we're looking for things that are greater than or equal to 0. So we're looking for positive intervals here. And my only positive interval is between negative 2 and 0. So that's the interval we're going to look at, from negative 2 to 0. Now we do have this equals to line underneath our inequality, so we would think about including those end values. But when we're dealing with a rational inequality, we need to be a little bit extra careful. Because we're dealing with a fraction, we would need to make sure that the denominator is never equal to 0. So as we're looking at that end value of negative 2, it's actually not safe for me to plug in negative 2 because that would give me 0 on the bottom. So I don't want to include that end value. It is safe for me to plug in 0. I don't have to worry about 0 in the denominator there. So I'm going to put a square bracket around that end value to include it. So here our solution set is the interval of numbers from negative 2 to 0, not including negative 2, but we are including 0. That's going to be it for this video. Thanks for watching.